Okay, welcome on in, everybody. Let's take a look at how everything's going to work for the following week so that there's no confusion and everyone can move ahead. For starters, I just noticed that we have some assignments that are due October 31st. Ignore those. I will change the dates on these so that they are due after the test. So we have time to come in, talk about them, and then go from there. Probably more like after the first week of November or something like that. I'll go ahead and change these. So don't worry about these. Don't try to do these yet. You should be focusing on stuff that's going to help you for the test. Okay, so the stuff, this intro to rash. In fact, I should just do it now probably so there's no confusion. Let me do it real quick off screen here. Otherwise, people are going to get confused about stuff. So let's go to view assignments. Let's go to Math 3 only. Okay, this one will move to let's make it that. I just noticed right before class those dates were messed up, and I know it's going to confuse people. And then this one, some of you have already done it, which is fine, but you don't have to do it until after the test. And I think there's one more in there. What's it called? Oh, I was in the wrong screen. The scroll bars are set up weird on Delta Math. It's kind of annoying. I have to go all the way to the bottom to scroll and then come back up. So this right here should be the last one, I think. So if I change that due date. And I may have to adjust those slightly again. We'll see. We'll kind of see where we are with things next week. Oh, there's one more I missed. Okay, hold on one second. Complex fractions. There we go. Okay, here we go. Corrected. So there should be no confusion. So when you go into the account, right, this is the student view. So when you go in there, top assignment, exam 1 practice, that's what you should be working on. Notice that those other ones, the rational expression stuff, we're going to deal with that stuff on the other side of the exam. If you already worked on it, great, but it won't be on the test. So this rational expression stuff we're dealing with after the exam. Okay, so you don't have to stress out over that. So I put together, it's a fairly lengthy exam 1 practice. Should probably take a couple of hours, but it's going to help you remember a lot of the stuff that we're looking at. So what are we looking at? We're looking at factoring, like lots of factoring, greatest common factor, factoring trinomials, factor by grouping, multi-step factoring, lots of factoring stuff, solving equations by factoring. Those are all pretty basic stuff from that chapter, some of the most important material from the course. Solving some systems of equations, right? Various problems on solving systems of equations. Graphing, can you understand a graph that you look at? Can you graph things from an equation, right? All that kind of stuff that we did early on. Now, here's what I'll say. Your actual exam will be significantly shorter than this practice exam. So if this practice exam takes you 2-3 hours to get through, that's fine. The test will not be that long. Okay, it will be significantly shorter. I would expect most students to be able to finish the test in 60 minutes, give or take 20 minutes. Some of you will finish it in 40. Some of you might take 80, but, you know, roughly an hour to take the exam. Now, what you should know is that the way the exam settings will work are different than the practice exam settings. The practice exam settings are set up like a homework assignment. So it's out there. You can work on it. You can start it. You can keep coming back. You can keep working on it later to get more points for half credit. The test will not work that way. The way the exam will work is that you will have a few days over which to choose to when you take the exam. So I'm probably going to have the exam. No, right. So there's a question. I don't have to finish the practice exam all in one sitting. No, that would be, I wouldn't even suggest that you finish it all in one sitting. Probably, 2-3 bites at this assignment would be good. So it's just like a normal homework assignment. You can stop, leave, go to work, take care of the kids, whatever it is that you do, and then come back and work more on this. The exam, the actual exam, you will be more limited, but again, it's shorter, okay? So I probably will have the exam go live Wednesday. Let's see, we're a Wednesday class, right? So the exam will probably go live Wednesday, probably after class. And so that means that you should pick the time to take the exam that works for you, right? So look between Thursday, and again, I might make it go live Wednesday, but start looking Thursday, Friday, Saturday, Sunday. Look at your life. Look at your calendar. Look at your work schedule. Look at your responsibilities if you take care of parents or kids or anything like that, and figure out, like, just give yourself, give yourself some extra time, 2.5 hours that people are going to leave you alone. There isn't going to be a bunch of noise distractions going on. You're not probably going to lose power, right? We were scheduled to lose power today at my house because they're still fixing the power poles from the fire, 4 years later. But it's raining, so they postponed it. But I was supposed to be without power now. So that stuff kind of can happen where you have power outages. So if there's a wind event coming, don't wait till Sunday night and then it's windy and then you can't work on homework or something like that. So pick a period of time that works for you. Kids aren't going to be asking you to make dinner and stuff like that. Where you've got 2.5 hours. You're probably not going to need all that, but you have it to sit down and take the exam undistracted. Okay, so the way it works is I usually have it set so that it gives you a bunch of time to take the test. I haven't made this test officially yet, but in the past I've given tests where the person had like 8 hours to finish it. But that starts from when you start it, right? So when you start the homework, a clock starts ticking for some, numerous hours that you have to work on it. Excuse me. So, sorry, I lost my train of thought there. Oh, right. So the practice test will have a little bit different setup than the actual test. So the actual test you should try to do in one sitting. You should be ready to go. You've done the homework, you've reviewed, you've done the practice test. You feel confident that you know how to do all the different types of problems that you need to do. And then sit down and try to get through the whole thing at once, because that clock's going to be ticking. You can't come back the next day and work on it again the way that you can with the practice exam. It's going to cut you out and say, sorry, you didn't finish these 6 problems. And then you'll get zeros on those problems, and then that's obviously going to hurt your grade. Now, don't panic. There is a retake available if people need it after the exam. But it's in your best interest to not have to take that retake, because that means next week you're going to be learning rational expressions and rational equations, which is kind of complicated for students. And at the same time, you're going to be studying for the exam, right? That's hard to do. You're much better off just getting yourself fully prepared for the exam this week and then passing the test and not having to do a retake. That's really the best way to go, okay? Can we take the practice exam more than once? It's whatever rules work under the normal homework assignments. So you can't start over from scratch, I don't think. But it's the same rules as a normal homework. So whatever you're normally able to do in a homework, you'll be able to do on this one. But I don't think it like erases and then you can start over or something. Okay, so you'll have that. You'll have that time available to take the exam. And then worst case scenario, you do terribly on the test. Well, there's a retake the week after. that you can get ready for. Okay. The test will be quite a bit shorter. I will only on the test. Some of these on the practice test, I gave you you had to do 2 of that type of problem. Remember, you have to get points. So you get 2 points in order to complete that objective and move on. On the test, I don't see the point of having repeat problems. So you'll just have 1 of each. So that already cuts the test in half. And then besides that, I'll probably throw out a few of these different types of, I won't have this many topics being covered on the actual exam. There'll probably be a few less. Okay, so that's kind of where we're going. The practice test does not look exactly like the exam. It actually covers more stuff, but I do reserve the right to, add a new problem in somewhere. I'm not going to add in something that's a surprise that you've never seen before. It'll be something that was on the homework or that we did in class, but I always reserve the right to insert a new type of problem in there. Sometimes people get upset and say, well, that problem wasn't on the practice test. Well, again, remember, you should not be trying to memorize how to do problems. You should be trying to understand how to do them. If you understand how to do a problem and I change it up a little bit, shouldn't really bother you because you understand how to think your way through the problem. If you've memorized a specific thing and don't really understand it, then when I change it, then you're kind of sunk, right? So don't memorize, understand. That's what you want to do. And then, work through this, get some practice. If you need more practice, I believe you can keep clicking the new problem or something, even if you've completed that topic. I think you can go back and do that specific one again. So are there any questions on the administration of the test? That is, like when it's available, how long you have to do it, all that kind of stuff. And you'll have till Sunday night is when I'll have it closed. That way we start all fresh on Monday with new stuff. So does anyone have questions on that part of things? Yeah, so the test, it won't be just like a Delta Math homework, but you'll be taking the test online, right? So it'll be an online portion of the test, so you don't really have to show work or anything like that. Just try to answer the questions and get them correct and stuff like that. So it'll all be online here. No showing your work. I think I mentioned before that there was going to be a written portion, but I decided not to go with that. I may still do it for the final exam in the course, have a written portion, but I actually think a lot of these problems on Delta Math make it pretty hard for someone to go somewhere else and just get the answer. So, okay, so if there's no questions on that, I think I answered the question here. So the only difference, the main couple of differences between the test and the Delta Math, it's not going to give you videos to watch. It's not going to give you hints and other problems and explanations. All that kind of stuff's going to be gone. And then you'll just have one chance at each type of problem. You don't just get to keep doing them over and over again. Oh, when is the exam available? The exam will be available Thursday. So you'll have between Thursday and Sunday to do it. I may release it Wednesday after class, but for sure you'll have it available to you Thursday through Sunday. The practice test keeps being available to you. So if you feel like at some point like, oh, I need to go work on systems of equations again, you can go kind of root around in the exam 1 practice and try to make sense of stuff that way. Okay? So so that'll be available to you, but you're limited in the actual exam. So guaranteed Thursday through Sunday. You can pick a time that works for you. Those of you who are ready to go, I may put it up Wednesday, and then you'll be able to work on it then. Okay? All right. And if other questions come up about how this is supposed to work, go ahead and ask. That's fine. But I guess we'll transition to, are there specific types of problems that people need to see? I know you haven't worked specifically yet on the practice exam because I only made it about an hour ago. I made the thing. So you haven't had time to look at it. But are there questions that you know you're going to have problems with, right? I mean, if you can graph lines and you can solve equations of lines, and you understand slope, and you can solve a system of equations, you can factor, and you can solve an equation with factoring, you're going to be fine. I guess there's some function stuff on there too, understanding the basics of functions. So those are the basic topics that are covered on this practice test and on the test. So if any of those had be specific, don't just say, oh, I don't get systems of equations. But if there's one of these specific types of problems from the homework that you need to see me go over, let me know. Because the way it works is if I just sit here and I pick problems and go over them, it doesn't mean that you as a student it doesn't mean anybody needs to see those, right? So it really works a lot better if people ask questions and ask me to go over a specific topic. Okay, let's take a look. In the solve by factoring equation real only section, I didn't quite grasp the square root thing for the answer. Can you go over that? Yeah. So that actually goes slightly beyond what we have looked at so far. So that's actually a great question because, let's see, so was it solve by factoring? Where is it? I think I left it out of the practice test, but we can certainly look at that. So let's do the solve. Let's take a look at this. Oh, actually, that's not quite right. Hold on. I've got a wrong one in here. Let's see. Yeah, that one can be done. Solve factored equation isn't good. Okay, I'm gonna have to fix this. I'll fix this after class, but this is not the section that I thought it was. It's a little beyond what we've done because it involves the square roots and stuff like that. So let me go back. I'll fix that later, but let's look at what's being asked about. So sometimes what happens in homework is we will give you a problem that is slightly beyond what we've taught you, okay? And that's actually good exercise because it gets you to sort of expand your skills on your own without just reproducing what you were told. And this is like that a little bit. We're getting into stuff that we will learn later in the semester, but I was putting it up there to see if some of you could stretch yourself. And of course, those are going to be more complicated, so it's perfectly reasonable to ask about those. So solve by, let's see, factor by grouping. Oh, I changed those dates. So it's in, let's see, I got to find this factor. It's not still due then, is it? Yeah. Oh, solve by okay, so that was the one. Okay, solve by factoring, and then it's factor by grouping, equation real only. Okay, so I think this is the one like we're talking about. Okay. So when it says find all real solutions to the equation, that means that we're looking at solutions that exist in the real numbers. We will learn about complex numbers in the chapter where we do square roots, but it's not asking for complex number solutions. It wants just the real number solution. That is, it's part of the real numbers. So it's confusing. There's this group called the real numbers, and it's just called that because the Greeks thought that those were the only numbers that mattered. That, oh, well, imaginary numbers and complex, they even called them imaginary numbers, the ones they couldn't figure out what to do with. But don't get stuck in that mindset. Complex numbers and imaginary numbers are actually really important. The name makes you think it's just some made-up game, but actually they use it in things like electrical engineering to represent resistance and current and stuff like that. We wouldn't have electric devices without imaginary numbers and complex numbers. We wouldn't have computers. We wouldn't have these computer phones in our pockets. So they're super important. But let's take a look at this. So 3x cubed minus 4x squared minus 21x minus 28 equals 0. So this problem I would not put on the test, right? This was put on a homework to kind of stretch you a little bit and see if you could expand. Like, are you up for the challenge of doing that? Some people are, some aren't, but it's a good exercise to do either way. Okay, so let's go here. So we're looking at 3x cubed minus 4x squared minus 21x minus 28 equals 0. And anyone else, get your questions ready for when I'm done with this problem so that you can ask about the one that you need to see, right? If no one's asking questions, then I kind of assume, all right, I guess everyone's ready to get 100% on the test, right? If you ask questions about where you're having trouble, then I can address those questions and help you. So let's see if I did this right. 3x cubed minus 4x squared. Oops. It's plus, isn't it? Plus 3x cubed plus 4x squared minus 21x minus 28. Okay, now see how I just went through and I double-checked what I had written down before I started the problem? One of the reasons I do that is because I see students do the opposite all the time, where they just go in, they write it down, and then they start working on it. And after 10 minutes of being stuck, they realize they wrote the problem down wrong. So always a good idea to double check that you actually wrote the thing down correctly. There's more times than you'd think that's actually people's mistake, was how they wrote the problem down. Okay, so when I see this, I think, okay, I've got an equation. Good. Step 1, get 0 on one side of the equation. Ooh, we've got that. Awesome. We don't have to do that. Okay, step 2, factor. There's 4 terms here that can't be combined, so I should instantly be thinking factor by grouping. Okay, so let's do factor by grouping. So let's see. I can pull an x squared out from the first 2 terms, leaving me with 3x plus 4. And from the second 2 terms, it looks like I can pull out a negative 7. Yeah, just a negative 7, leaving me with 3x plus 4 equals 0. Remember to always keep it an equation. Don't change it to a non-equation. Okay, and the good news is my 2 binomials match, so I can pull that factor out. So when I do that, I've got the 3x plus 4 that I pulled up to the front, and then I've got an x squared minus 7, and still equals 0. We're still keeping that equation in there. Okay. Now, what do we do? Now that we've got it factored, we set the factors equal to 0. So either 3x plus 4 equals 0. And remember, we're expecting 3 answers because it's a trinomial polynomial that we're factoring, right? So either 3x plus 4 equals 0, or x squared minus 7 equals 0, right? You set each factor equal to 0. And then we solve these. So the first one's not too bad. That's going to be, what, 3x equals negative 4. If I subtract 4 from both sides, then dividing by 3, I get that x equals negative the fraction 4/3. So one of our answers is negative 4/3. Now, you know how I've always been telling you to check your work, right? Now's when it really matters. On the homework, if you didn't check your work, all it meant was you lost a point and you had to do 2 more problems to get back ahead again, right? Here on the test, you're not going to have multiple attempts at the problem. You're going to have to get it right. So you really, even if you haven't been doing it previously, check your answers before you plug them in. Now, admittedly, when it's a fraction, it's harder to do. When you get an integer like 4 or 2, it's pretty easy to plug into a polynomial. When you get a fraction, a little bit harder, but that's okay. It's still doable, but a little harder to do. Okay, now here's the part that's new. Here's the part that we didn't strictly go over, and which we'll be going over. I think it's two units from now. We'll be going over, basically 2 chapters from now. We'll be going over it. How do I do the part with the x squared minus 7? We technically don't have, we'll go in more in depth with how to do this, but I'm just going to show you basically how it works now. Okay, good. We got the next one lined up. Okay, so if I add 7 to both sides, I get x squared equals 7. So just kind of think about this for a minute. What kind of numbers, when you square them, give you 7? Well, by definition, one of them would be the square root of 7, right? When you square the square root of 7, you get 7. What about the negative square root of 7? What if we have negative square root of 7? Well, a negative times a negative is positive, and square root of 7 times square root of 7 is 7. Therefore, this tells us that one of our answers is x equals the square root of 7, or x equals negative square root of 7. So we have 3 answers: negative 4/3, square root of 7, negative square root of 7. If you take any of those 3 numbers and square them, if you take any of these 3 numbers, plug it into the original polynomial, they should work. Now again, this is a little more complicated than I'm going to ask for on the exam, partly because we haven't covered square roots yet. But you can kind of think your way through it here by going, well, what do I square to get 7? Well, the square root of 7 is what I square to get 7. So let's just double check that I got this right. There's a lot going on. So negative 4/3, comma, square root of 7, comma. Also, if you do SQRT, it makes the square root sign too. That's fairly standard in math software. So, I can see it's not really on the screen. You have a little square root button right here. Oh, and you even have a plus or minus. You can do it that way if you want. But so if you hit the square root button, you get the square root sign. If you type SQRT, you get the square root symbol. So they both work that way. And then if I put 7, except this needs to be negative, we got it. Okay? But again, that's a little bit okay, good question. Good question. So the question is, so you could think of it that way. Isn't x squared minus 7 a difference of squares? Well, 7 is technically not a perfect square. It is a square of something. So you could factor it and get x plus the square root of 7 and x minus the square root of 7 if you did it that way. But usually when we factor, we talk about factoring over the integers. And the question you have, that's actually a good way of solving the problem. That would totally work. But you'd still end up with the square root of 7 and the minus square root of 7. Yeah. So don't stress about this problem too much. It's great that you're asking because again, that's kind of the point of that homework problem is to try to get you outside your comfort zone and get used to like making sense of some of these problems. Even when you don't have full knowledge and you haven't seen full examples, but I won't put this on the test. So if you don't 100% understand this problem, that's okay, right? You actually you did pretty well with it, okay? And I won't test you on it. We'll learn it in a couple weeks. Okay. All right. So then factoring trinomials level 2. So that's a question we want to look at. Okay. Factoring trinomials level 2. Factoring trinomials level 2. Okay, let's take a look at one of those. Okay. Factor completely. 5x squared plus 4x minus 9. Okay, 5x squared plus 4x minus 9. 5x squared plus 4x minus 9. What are we doing? Just factoring. We're not solving, right? Again, just to make sure people are clear, two things you should always check when you're looking at these. What are the directions? This is telling us to factor. And what do I have? An expression, so you can't solve it, right? You can't solve an expression. You have to solve an equation, and it's telling us to factor. Okay, so I remember what we're doing now. I'm factoring, and it's 5x squared plus 4x minus 9. 5x squared plus 4x minus 9. Okay, I got that. Okay, good. Okay. And feel free if someone wants to throw in that next section we should look at in case I missed one or something. Go ahead, get that next one ready because I think we're going to have a few minutes where I can go over another type of problem if anyone wants to see it. Okay, so these ones where the a, that is the coefficient on the x squared, is not equal to 1, these take a little bit of work, right? This one I think isn't going to be too bad because we've got a little bit lucky. The coefficient on our x squared is prime, which means there's only one way you can break it down. It's going to have to be 5x and x. Now, this one's a little bit more, so we kind of got started here. This one's a little complicated because since this is a negative, that means that my signs in my factored form, there's going to be a plus and a minus, right? Because that's the only way when we do the L part of the FOIL that we get a negative number is when the signs are different. So I have to go, okay, there's going to be a plus and minus down here, but I have to be careful because I don't know if the plus goes after the 5x or if the plus goes after the x. We don't know that yet. That makes it a little trickier. Okay, so now what I'm going to do is look at 9 and think, what are the different ways I can break down 9? And luckily for us, there's only, what, 2? Either 9 and 1 or 3 and 3. So we need to know, is there a way where I can put 3 and 3 in here or 9 and 1 in order to make the middle have a difference by 4? Remember, we're working backwards through the polynomial multiplication process. And we have to, it's weird because you're reverse engineering it in your head. You're thinking backwards. But essentially, what we're looking at is a guess and check scenario. I'm going to look at the clues of this polynomial and make my best guess that I can come up with, and then we're going to see if it's right. The stuff I have written so far we know is going to be right, but the rest of it coming out is going to be my best guess. So let's see. I'm guessing it's going to be a 3 and a 3. So let's see. I'm going to put in a 3 and a 3. And then I don't know if we're going to have a plus or a minus. Let's see. So I just did this problem. It's not like I've done this ahead of time. So I'm probably wrong on my first guess here. But I'm just going to see. Let's see. What does this come out to? So that's going to be 5x squared. Okay, we're going to have minus 15x plus 3x minus 9. Is this going to do it for us? No, because minus 15x plus 3x will give us minus 12x in the middle, and we want a plus 4x. Oops. Sorry, this is kind of off screen. Let me move that over so you can see it. Okay, so this is wrong. Okay, so we just did guess and check, and it was wrong. Okay, so now we're going to try something a little different. Okay. Let's see, actually, let me do this. depending on where I put it on the screen, it wants to spill over to the other monitor. Let's see. And let's move this over to here. There, that should work. Okay. All right, let's see. What if I do plus the other way? Maybe it is 9 and 1. Let's see if we get. Oh, it is probably 9 and 1. Let's take it. Let's see. Okay, so now you just try something different. Okay, so let's try it. We know it's going to be 5x and x. And then I think I'm going to want the 9 and the 1. And I'm going to want a plus and a minus. Okay, so now my guess is that it's going to be 5x plus 9 times x minus 1. And it's just practice. The more you do these, the faster you're going to see those combinations, right? So, and I could be wrong, but I think that's what it is. Let's see. 5x squared minus 5x plus 9x, there we go, minus 9. So see how in the middle I've got negative 5x plus 9x? That's 4x, which is exactly what we wanted. So when you simplify this problem, it's right. So it took a little guess and check. So the guess and check doesn't just mean randomly guesses, just randomly throw out guesses till you get the right thing. That'll take forever. You want to look for clues and fill in as much of the cases as you can, and then you resort to, you just take a guess, your best guess, educated guess on the remainder of the pieces, and then you multiply it out to check it and see if it's right. So 5x plus 9x minus 1. 5x plus 9, x minus 1. And there we go, right? Okay, hopefully that was helpful. Trinomials are hard, namely because like guess and check is not super satisfying, right? People go, oh, how do you do this? And then you show them guess and check, and they're like, well, isn't there a better way? Trinomials are just kind of weird with the combinations that you come up with. There is another way. You could use the factor by grouping method, but usually students don't want to do that one either. They don't want to do it that way. So it's up to you. You can, for trinomials, you can use guess and check. You can use that factor by grouping method that we looked at. Either one, totally legitimate. Just depends what your brain prefers. Okay. All right. Is there another problem? We have enough time to cover another topic. If somebody wants to see something else, we can go over that. So stuff that gave you problems from the homework, anything like that. No, not seeing any questions. Okay, then I guess what I will do is for the remainder of class, I will just be available in Zoom to help you with whatever you want. Any kind of questions that's, you know, in some way school related, come ask them, and I will help you out with that. So I'll close down the YouTube stream. We'll talk further on Wednesday. Now, here's what I hope for Wednesday. I hope by Wednesday, many of you have worked on the practice test, and you're going to let me know which of those problems you want me to go over, right? If there's no questions, that tells me that every one of you is ready to get 100% on the test. Otherwise, if there's problems you don't understand, send them to me. Either email me a screenshot, or like some of you are doing very good in the chat where you're like telling me specifically what the section is called that you want to go. Oh, piecewise functions. Great. Let's go over those. Okay, let's do some. Oh, did I close down the? Is my delta? Yeah. We can look at piecewise functions for sure because those are on there. Did I accidentally close the? Must have closed delta math somehow. Let's see. Okay, let's go student view, math 3. Let's let's see. So we've got some piecewise function stuff in here. Here we go. Evaluate piecewise functions graphically. Let's take a look at that one. And by all means, we can talk about piecewise functions next time as well. Oh, you want that one graphing? Let's see. What was this one? This is evaluating piecewise functions, and you want to see graphing piecewise functions. Okay, we can do that. Yes, let's look at that. Okay, so the way you read this is that this function has two different functions that it's based on. We're used to having a function where it says one rule, like 2x plus 1. That means every time you ever use that function, you double it and you add 1. Well, a lot of times in the real world, you have different cases, right? And you have different functions that work over those different cases. Like if you're a company and you sell a product, a lot of times if people buy a large amount, you give them a cheaper price, right? So your price would change depending on how many items people are buying, okay? Well, here we have two different functions. When x is less than -2, it's equal to this function. And when it's greater than 1, it's equal to this function. So what that means is these are x values. So remember, this is your x-axis. So when it says x less than -2, that means, right, this is where x is equal to -2. So right from here to the left is going to be this first function, x plus 5, which is the line with slope 1 and intercept 5. And then for x greater than 1, so that's right here is 1, everything to the right of that, the function's going to look like this. Okay, so this one on the right's a little easier. When x is greater than 1, f of x is equal to 4. So it's just the constant function 4. And we're supposed to what? Graph it. So it would be here. Making it an arrow. Did I do that wrong? That doesn't look right. Oh, let's just delete the whole thing. 4. There, with an arrow on the end. I don't know why it's still putting the dot. That's kind of weird. So it should look like that. So for x greater than 1, oh, and this one should be a hollow dot, right? Because it's greater than, not greater than or equal to. So when x is greater than 1, that means we're on this part of the graph over here, because this is where x equals 1. So then when x is greater than 1, your function acts like the line y equals 4. That's what we have here. Okay, but over here where x is less than -2, it acts like x plus 5. So we actually want, let's see if it's going to let me do this. Oh, wait, it's, yeah, x plus 5. So we actually want to move this one here and then delete that. No, it's not going to let me do that. Okay. But it's going to start here. And go down. And it should be what? Hollow dot there because it's a strictly less than right here. And then it looks like x plus 5, slope of 1, 5. And then this side it should be an arrow. And let's submit that answer. Yep. So so that's what we did. The function f of x equals 4, that's just a horizontal line. That works when x is greater than 1. So that's over here. When this is x at 1, so when it's greater than 1, it acts like this. F of x equals x plus 5, that's this line right here. Starting here, again, a hollow dot because this is a less than, not a less than or equal to. It doesn't exist at -2, but then it goes this way forever. Okay? So that's what it looks like. Okay? We can definitely go over piecewise functions more next time. I know that is a very common confusion point for students. So we absolutely can talk about that next time too. Okay? So we'll probably wrap up there. Anyone who wants to hop into Zoom and ask me questions, go ahead. Otherwise, please be collecting questions for Wednesday. Otherwise, we're just going to be staring at each other. Why did I start at 3 on the Y? Oh, okay. So if we just graph the question x plus 5, it's going to be this whole thing, right? It would be this line that starts here and goes up. You could get that by plotting points, right? At -2, if I stick -2 in for x, I get -2 plus 5, which is 3. So the y value is 3 at this endpoint. So you get it by plugging the x value into your function. So plug -2 in here. -2 is less than, well, it's right at -2. So we use the top function, but -2 plus 5 is 3. So we use that function value. Okay? Yeah, good question. Okay, so come see me in Zoom if you have questions. Otherwise, bring me questions for Wednesday. You can email me a screenshot of a problem that you want me to talk about, or like many people were doing today where they were giving specifics about the problems, about which one they wanted to see me do. That works really good too. But bring that on Wednesday. Otherwise, we're all going to be just sort of looking at each other. Okay? All right, thanks, everybody.